All right, so I'm going to go over polynomials and rational functions. I'm going to do them not in the same video because, I don't want these things to be years long. So you probably remember polynomials, right? So if you want to be really fancy with what a polynomial is the sum or the difference of a variable raised to non-negative. That's basically positive numbers as well as zero, integer values, or I'll just go powers. So for example, if I just kind of said, hey, I have 5x cubed plus maybe 2x squared plus 6x plus 7, this is a polynomial. But if I had something like, for example, 5x cubed plus 2x squared plus 6x plus 7 plus, say, x raised to the negative first power, this would not be a polynomial because this x to the negative 1 kind of screws everything up. We have x being raised to a negative power, right? A negative integer, right? So that screws that one up. So if we want to get standard form of a polynomial, right? So standard form, if I say p of x is going to be my polynomial. So we'll generally write it like this: a subscript n, x to the n, plus a to the n minus 1, x to the n minus 1, plus a to the n minus 2, x to the n minus 2, plus dot, 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 a1x plus a sub 0. Right, so this would account for any possible value of n, and n can go up as high as we want. So we would say where n is a non-negative integer. If we want to be fancy, we would say something like n is an element of, that's like our little symbol for the non-negative integers if we really want. So n is a non-negative integer, and we'll say a to whatever thing, right? So I'll just say a sub k is a constant. Right, so any of these values of a, right? So in this case, k would be 0, k would be 1, k would be 2. So if we want, again, k would also be a non-negative integer if we really want to write it that way. So if I looked at this good example, right, this would be a sub 3, right? Our power of n is equal to 3. This would be a 2, a 1, and a sub 0. Now, we don't have to have all of those terms. If I wanted to, I could just say 5x cubed. Perfectly fine. That's also a polynomial. 5x cubed plus 11, also a polynomial, right? I don't need to have every single one of these terms kind of like top to bottom. When we do have standard form, we tend to write them big to small. So we put our highest power of x to the left and our lowest power of x to the right. So there's some special ones here. We'll see a little bit later, right? This a sub n, that's going to be important. This is called our leading coefficient. And this last term, all the way here at the end, right? This a sub 0, that's going to be our constant term. A bunch of everything, like the coefficients are all constants, but that's the constant term is going to be the y-intercept. Right, so we could also have factored form of a polynomial, right? So assuming that this thing kind of like factors kind of nicely, we'll generally write factored form this way, right? So we'll have some power, some number that we can pull out of everything if we want. We'll have x minus, I'll say r1, x minus r2, dot, 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 x minus r to the n. And these r's can, they can repeat. Right, so basically these values of r would end up being the x-intercepts. Right, so we'd say that r sub I is, or we'll do a k, so use a k before. Rk is an x-intercept, also known as a root, also known as a 0. Right, so this factored form gives us nice information. It lets us really quickly figure out, hey, where our function is going to hit the x-axis. Again, this should generally be some sort of review for you. Maybe the notation that I use a little off, a little different, but hey, we're in big boy and girl math at this point. So a couple of other things that are important. The degree is important. The degree of the polynomial is the highest power of x. Right, so this highest power of x, right, would be this, in this standard form, it would be the value of n. In this example that I had up there, n would be 3, right? It's 3 is bigger than 2, 1, and like technically if we were really being precise, right, this is x to the 0. because x to the 0 is 1, right? So 3 is the biggest exponent power that we have. So the degree of this polynomial would be 3. Sometimes we also call it the degree, the order of the polynomial, right? So we care about this kind of degree and power because it's going to help us out with the long-term behavior of a polynomial. And this is important for a couple of things. When we talk about table of signs, when we talk about kind of end behavior, all of this kind of comes into play, limits as well. So a parent function of a polynomial is basically the most vanilla form of a polynomial you can have. Technically, it's the function or the polynomial before we start adding on any transformations, like shifting it up, down, moving it left, right, before we start adding on terms. So each of these functions would be parent functions of polynomials. All right, so in terms of shapes, whoops, that's a highlighter. So f of x equals x is just a line, a linear function. It would look like this. F of x equals x squared, that's a quadratic. It would look like this. X cubed looks like that. X to the 4th power starts looking a lot like x squared, right? So it's going to look like our quadratic is going to come down a little bit more, have a little bit of kind of like a flatter base than x squared would have. X to the 5th power is going to look a lot like x to the 3rd power, but it's going to kind of come up faster, get a little bit more boxy as we get around the origin. By around the origin, I mean between positive and -1. And in fact, x to any even number is going to look like x squared, right? The higher that even power is, the more boxy it gets at the bottom. So any x to the even power is going to look like that. And x to any odd number that's bigger than 1 is going to look like x cubed. And again, it just kind of gets boxy by the origin between positive and -1. So I'm going to do limit notation in the next video because this is good enough and I haven't messed up yet in the past couple of minutes and I want to keep that good mojo going.